All right, today we are doing double angle formulas, power reduction formulas, and half angle formulas. So first, we're going to start by deriving one of the double angle formulas for cosine. So we're going to use the addition formulas for this. So we can rewrite this as cosine of x plus x. We have a 2x in there. And using the addition formulas, you'll get cosine of x times cosine of x minus sine of x times sine of x, which is cosine squared minus sine squared. And then if you replace the first cosine with 1 minus sine squared, you still have another sine squared. You get 1 minus 2 sine squared of x. And if you look on your sheet for your trig identities at the double angle, that is right here, 1 minus 2 sine squared is one of those options. So here are the double angle formulas. Again, these are on your sheet, so you don't need to memorize them, you don't need to write them down. Sine and tangent each have 1. Cosine has 3 of them, and it doesn't really matter which one you pick. Often there's one that's easiest, but you can always switch between them pretty easily. So pick one. If it's not working, switch back to a different one, or just rearrange it, and it should work out just fine. So we're going to use those to prove this identity here. I'm going to start with this side. Again, you can always start with the other side and work through it. It should still work. So I'm going to do sine of 2x plus x here, and then use the addition formula for sine. We'll get sine of 2x times cosine of x plus cosine of 2x times sine of x. So again, to label, this would be your a, this would be your b value in the formula. Okay, and then for this chunk right here, we'll highlight it. I'm going to do the double angle formula. So it will become 2 sine of x cosine of x. And then this cosine of x still has to come down. And then I'm going to use another double angle for this one. And since we're trying to get all sines, if we look over here, all of these are sine, I'm going to use the cosine double angle that is sines. But again, it doesn't really matter. It's just be 1 minus 2 sine squared x, and then times sine of x. So if we keep simplifying, this is 2 sine of x cosine squared of x plus sine of x minus 2 sine cubed of x. Okay, now at this point, I'm going to replace this cosine squared with 1 minus sine squared to get 2 sine of x, 1 minus sine squared. We still have the sine of x minus 2 sine cubed of x over on the end. So then distribute this in. 2 sine of x minus 2 sine cubed of x plus sine of x minus 2 sine cubed of x. At this point, I'm going to combine like terms. So you get 3 sine of x minus 4 sine cubed of x. So you have my equals on all of these. And the last step is going to be to factor out a sine. So you have sine of x times 3 minus 4 sine squared of x. And that's what you were trying to get to. So I'll zoom out so you can see it all together. But that's the process. So lots of like slow algebra, but nothing super duper complicated. So the power reduction formulas are here. This is to go from like a squared down to just an x, or like to the fourth to a square. You're going down a power, which is power reduction. So an example here we have cosine cubed of 3x equals a half cosine of 3x plus 1, or times 1 plus cosine of 6x. So again, I'm going to start on this side here and rewrite this as cosine of 3x times cosine squared of 3x, just because my power reduction formulas has like a square in it. Here, the x value that we have is 3x. So in the formula, x is going to equal 3x. So I'm going to leave this cosine of 3x alone, and then plug the 3x into the formula. So you're going to get 1 plus cosine of 6x all over 2. This 6x comes from 2 times 3x, since we had this 3 to begin with. And now you can simplify from here. So this 1/2 can come out front of everything. Then you have your cosine of 3x, 1 plus cosine of 6x, and that's what you wanted. And you're done with that one. So the last things we were doing were the half angle formulas. So here you have sine, you have cosine, and then tangent has 2 options. It doesn't matter which one you use. It doesn't matter at all. Pick one, go with it, it's fine. So if you want to find this exact value, it's a weird decimal. So if you multiply by 2, you're going to end up getting sine of 135 over 2, and then you can use the half angle formulas. So you'll get plus or minus, and if we plug it into the formula, you have 1 minus cosine of 135 all over 2. Use your trig values sheet and 1 minus root 2 over 2. And then at this point, there's a bunch of options to simplify. So you can find a common denominator, multiply where there's a rule of 2, but I'm going to clear the denominator here because I want to get rid of this 2. So I'm going to multiply this whole thing by 2 and this whole thing by 2. So like 2 over 1 and 2 over 1. So we'll end up getting here on top, this 1 is going to go with this 2 to become a 2. This 2 will cancel here, so you get minus root 2. And then these two 2's will come together to become 4. So at this point, I'm going to break this up into 2 square roots. We get 2 minus root 2 over root 4, which will give you plus or minus root 2 minus root 2 all over 2. So kind of a goofy answer, but that's what you should be getting. Did I do that right? Oh, this should be a plus right here because sine of 135 is a negative. And there you go. So check Schoology for your assignment. If you have questions, talk to me, Mr. Anderson, or Mr. Herbenson, and we'll answer them.